Hey everyone, welcome to today's Training Tuesday. I'm Heidi Reese, the Training Programs Manager at Dayton Superior. Sitting here in lovely Dayton, Ohio, we've got Todd Fraker. How's it in Colorado, Todd?
The weather is nice, 67 degrees for a high.
Oh, fantastic. We should all be having a picnic and then talking about non-shrink grouts. So before we get started, I want to let everybody know and remind you that you have joined muted so that we can go through the presentation without any outside disturbances. And we also record these so they are placed out on the YouTube Dayton Superior channel, as well as DaytonSuperior.com. You can search for Training Tuesday and find all of the latest and greatest. And we've organized them by the subject matter so you can get to them as you need. Now, real quick to go through, this presentation is intended for training purposes only. So just want to remind you, any products that we talk about, anything that we discuss as far as applications, please make sure to go to DaytonSuperior.com and get the technical and safety data sheets, specifications for the products that we're talking about. And real quick, as you want to get to the good part of the non-shrink grout training, Dayton Superior doesn't just offer the chemicals like we're going to talk about today. We've got Simon's forming and shoring. It's very adaptable, strong systems, saves labor costs. We've got more chemicals on the concrete repair and restoration for meeting the design specs that you might need for both new construction and retrofit. We also have bridge deck accessories, rebar splicing, precast and tilt-up construction. But most importantly, we've got the engineering solutions that can put all that into, if you've got a challenge, we're here. We've got the largest engineering group in the industry, and we stand by that with our products and training. So if you need additional training, like you're getting something here today, real quick snippet from Todd, you can also get in touch with Chuck and myself through training at DaytonSuperior.com. Once again, that's training at DaytonSuperior.com. Just tell us what you need, or hey, you want to do more special things at your place, our place, whatever, we can talk about it. So let's get to the good stuff. But first, I want to introduce Mr. Todd Fraker, who is having wonderful weather up in Colorado, or to the side of me, I should say. He's one of our chemical technical sales reps here at Dayton Superior, and he has been with Dayton Superior for over 41 years. So him and Chuck like to hang out. If for those of you who are constantly on these calls, I'm always giving Chuck some good time. He's out training, by the way. So Todd's been around the block a time or two regarding chemicals, so he's great to have you, any challenge that you may have, he's going to answer those questions for you. So I want you to get those questions started, and you can ask them through the Zoom chat functionality to me, or raise your hand, or do the Q&A, and we'll be sure to make sure that you get them answered at the very end. In addition, Todd has past roles consisting of dealer sales manager, regional sales manager. He's been the senior chemical manager. I'm sensing a theme here, right? And he's also got a bachelor's of science in chemical engineering. And like I said, he's great to work with, and he's a plethora of information. So I'm going to shut up and let him tell you about the information. Take it away, Todd.
Thank you, Heidi. Good morning, everyone. Looks like we've got a great group on here. Looking down to the names, I see some familiar, some not so familiar. Dan Coronado, special shout out. Aloha. Hope things are going well in Honolulu.
Oh, talk about nice weather.
Yeah, 82 and sunny. What's the weather? We're going to focus on grouts today, primarily cementitious grouts. We will touch on epoxy grouts, what it means. Everybody's had a chance, has been in sales for a while, to look through a set of specifications. Usually the engineers are pretty specific about what they want. Oftentimes we'll just see grout and they'll put down a specification for it, and that's what you're going to end up selling to your customers or using. Occasionally you get a ringer where they'll call out a grout, and grout in a broadest term means anything that can fill a void or transfer a load. So just keep that in mind. So grout doesn't always refer to a bag good that weighs about 50 pounds. So we're going to go through the main specifications, the types and characteristics, applications, the most common applications, testing, mixing and placement, and of course, give you resources and tools at the end of the presentation where you can reach out to Dayton Superior. We love to solve problems. We love complicated applications. We've been products for a long, long time, and we're very, very good at what we do. So that being said, let's move into the presentation some more. All right. A non-shrink grout is a proprietary blend of specially graded aggregates, Portland cement, or epoxy, or other ingredients designed for transferring load, anchoring, and filling of voids. I really take offense when I hear people say it's dirt in a bag. There are a lot of different quality ranges on grout, sources of aggregates, types of cement that are used in the grout. And we pride ourselves at Dayton of having always sourced the level, the cements and the aggregates that make the product kind of the workhorse of the industry. It's one of the more well-specified products, especially the 1107 and the high performance, any other grout in the market. Clarification, it is not the same as masonry or tile grout. Again, tile grout can be sanded or unsanded, but it is used for filling a void, hence the term grout, fills a void. All right. ASTM 1107, which is the main governing specification of grout, says that non-shrink grout is intended to use under applied load. So for our intents and purposes, all our cementitious grouts do transfer load. You'll notice in that picture above on a tile grout, that's not transferring any load at all, it's simply filling a void. Let me get my clicker going again. All right. Two main specs that are out there for years. The Army Corps of Engineers had their CRD C621, and in 1993, they decided to go ahead and kick it over to ASTM, which is the main governing body for most standard specifications in the U.S. for most all products, including baby strollers and safety helmets. Grouts fall under specifically the ASTM C1107, and within that 1107, there's about 12 to 13 other sub-specifications that actually define how the material is to be used, what strength it's supposed to reach, and how it's to be tested. All right, so the types of grouts really that are prevalent that we're going to be talking about for construction: cementitious, non-metallic grouts. They're dense, they're water and chloride resistant, they're resistant to freeze-thaw cycling, they're commonly specified, readily available, and cost-effective. Now, the whole notion of density comes from the fact that they develop such a high strength generally. 1107 in a flowable consistency will hit around 10,000 psi, as compared to concrete, which maybe hits around 5 to 6. So it does have more density, therefore it is more resistant to water intrusion or absorption of water. Therefore, it can resist freeze-thaw even better as well. Metallic grouts have been around since about the 1920s, when they started putting metal in to replace the graded silica aggregates. They were used on a number of projects around the U.S. An old name in the industry was Master Builders. They were kind of the forerunner of metallic grouts. In fact, my understanding is the Harley-Davidson plant in Milwaukee, Wisconsin, still has metallic grout in place from 1927. So that's a long time. Now, generally, metallic grouts don't last that long. Better technology has come along and have gotten us the compressive strengths that metallic grouts used to have. Epoxy grouts have very high bond strength. As you can imagine, they're sticky when they're wet. They have very high compressive and tensile strengths, and they have very high early strength gain. More importantly, they have high impact and chemical resistance, which makes them preferable in applications where the grout is going to be exposed to any kind of chemicals. That could be food manufacturing plants, particularly oil and gas, or anywhere where the grout is going to be exposed to a corrosive environment. Most commonly in our business, if you're working in commercial construction, the ubiquitous base plate, there it is at the top. That's a steel column coming out of a caisson or a pier. Very common in tilt-up construction, very common in commercial construction, any place where you're using columns in conjunction with piers and supporting loads. And you can see the grout between the base plate and the pier. Down below is a picture of a machine grouting application, which is using epoxy grout. That's used in applications where we need high transfer of load and great ductility and is able to withstand vibration. All right, a quick little picture here. We've got a bearing area, the base plate. We have the non-shrink grout, which is transferring the load from the base plate to the concrete foundation. Pretty straightforward. A non-shrink grout must not bleed and must expand after hardening. Now, this is the key point. We all know that concrete shrinks when it cures, right? It has maybe up to a 1, depends on what the water cement ratio is, but it can shrink up to 1 to 2% by volume. Non-shrink grouts, by their very nature, are meant to have slight expansion, so there's never any shrink back from the load that's attempting to transfer, i.e. in this case, a base plate. So given those parameters, all non-shrink grouts have to pass the 1107 expansion mechanism to compensate for shrinkage. So you may hear them referred to as shrinkage compensating grouts. I will never see anything coming out of the back of a ready-mix truck that is so-called shrinkage compensating. So beware. All right. Surface prep, straightforward, clean and free of dirt, oil, curing compounds, and latents. If you're going against steel, we want it down to white metal blast, particularly if you're using epoxy grout, so it'll stick. Quite honestly, under a base plate on a tilt-up or a commercial construction where you'd see a steel column, nobody's going to get under there and steel blast it, but it should be clean, right? They can get under there with a brush maybe, or clean it at least before they put it in place. Most often the surfaces of the pier that is transferring the load to, or the concrete substrate, is rough to begin with because they haven't spent a lot of time roughing it. Now, ACI does like the substrate to be saturated at least 24 hours prior to placement with water. We know that's not practical, so at least get on there in the afternoon. And in 9 times out of 10 cases, and I've spent too much time around construction to know that they get out there, they'll throw a little water in there with their masonry brush, and then they'll start grouting. So try to dissuade them from that habit and try to get some water in there. And that can be either through wet burlap or some other method where it's not onerous for the contractor to wet the substrate. But in all cases, what we're trying to do is we're trying to stop the dry concrete that the grout is placed against from starving the grout for water. If the grout loses too much of its mixed water, you're going to end up with subpar compressive strengths and a poor grout placement. Lots of mixing equipment out there for grouts. You got to look at the type and what you're doing. The largest grout job that we were on the last couple, well, actually 4 years ago, was the Houston water treatment plant. And we set up mixers that would mix about 1 to 2 yards at a time. They're substantially larger than what you're seeing here in this picture. In the middle is a mortar mixer with a moving blade. Notice that these are different than concrete mixers. I should have put a concrete mixer on here with a big X through it saying don't use. Why? Because concrete mixers tend to load up the grout on the blades and not mix it completely and thoroughly through the whole mix. Mortar mixers with rotating paddles tend to mix the grouts very well. Also good for epoxy grouts. There are grout pumps available. Chem Grout down there on the bottom, that's a pneumatic pump, and that'll pump it right through a 1 to 1.5 inch line. When we're doing mass grouting applications, oftentimes those are indicated to reduce the amount of time that batch mixing would require. There's a nice little hand pump. I see those in dealers still to this day. People do buy them and use them. It's very helpful when you're going into a very tight area and you need like a 1 inch line, mix the grout up, put it in a little funnel, and then start pumping on the handle. Another large batch mixer is the far right bottom, and that's also a Chem Grout product. Chem Grout seems to be the leader in these things, so we always defer to most of their products when people ask me for what type of grout, continuous grout pump I'd like to use. Mortar mixers are always preferred over concrete mixers. Never use a concrete mixer for mixing grout. All right, small quantities obviously are mixed in pails every day. Always put the water in the bucket first and then add the powder to the water and then start the mixing. Like to see 5 minutes on the drill, slow speed, not mixing a lot of air into it to get thorough wetting out of the cement particles in the grout in order to ensure good compressive strength when we're done. All right, we talked about water. Preconditioning of epoxy is a little bit different. If you've got very, very cold substrates, that's going to transfer into the epoxy, even though the epoxy grout tends to exotherm or give off heat as it cures. So if you're working in a very cold application, I recommend that they build a hooch or hooch up around the application in order to bring all the substrate and the epoxy grout into at least a constant temperature. And I mean something up above 50, because lots of oil field applications in the West require them to work throughout the winter to keep natural gas flowing throughout the U.S. And oftentimes are working in very, very harsh conditions. Most contractors know that they need to provide for these environmental constraints and provide a way of keeping the substrate and the application warm. Epoxy, you're going to mix the A and the B. It's a 3-part product. It's the A part and the B part. You're going to mix that first, and then you're going to add the prepackaged aggregate, which is a little bit more specialized than just sand. It has various thickening components to it. It has things that help disperse the aggregate throughout the mix and keep it from settling out. So we do provide the aggregate with all of our kits, our epoxy grout kits. All right, grout placement, a lot of different ways of doing it. If you're working under a base plate, the use of a head box is a great idea to provide pressure, downward pressure on the grout to force it to flow under the base plate. One thing we did not show is strapping, where they just take a piece of metal strapping and pull the grout across the base plate to the other side. And I'm going to show you another little trick with a safety cone. All right, there you can see the grout, cementitious in this case, flowing under a base plate. We answer a lot of tech calls around here, and in our data sheet, we say anything greater than 3 inches that we should extend the grout with aggregate. Now, why is that? The cementitious grouts generate a great amount of heat. And if that heat is not dissipated, the grouts will tend to thermally crack. And then we get a call, then the engineer gets upset, and everybody has to take the grout out. We got to redo it. I will say this, that's your rule of thumb to go by. I have approved grout placements as deep as 8 feet deep in an annular space, which is the distance between the metal, say they're grouting in a metal lining inside of a concrete tube. That annular space can exceed 5 inches, 8 feet deep, but you've got a lot of substrate to dissipate the heat off the grout. So there's lots of geometries, if you will. So the 3 inches are in the data sheet, but I will say this, if you give us a call or a customer calls us, we will walk through it and decide whether or not it makes sense. 3 inches deep is a good rule of thumb, as we said, but if you sell them some pea gravel to go with it, you do reduce your amount of sales on the grout. Most contractors don't like to have to add pea gravel to it. They just want to use what's in the bag and be done with it. All right, form should extend at least 1 inch above the bottom of the base plate on all sides. That's the form of shoulder in all cases. We could get into a half-hour discussion about geometry of the forms, forming shoulders, 45-degree chamfers. If you remember from those earlier pictures, the reason we put the 45 in there is to prevent chipping and so that the load transfers evenly throughout that whole thing. It's just a good practice that we've learned over 80 years of grouting, that a 45-degree chamfer going into the base plate will prevent the cracking and does expose the shoulders to wear. I think the rest of it is pretty straightforward. It should be quickly and continuously placed. You don't want the material setting up while the guys go to lunch. then they come back and realize they've got 1/8 of an inch between the grout and the substrate, and the grout below it's already hardened. So always place grout from one side of the structure to the other, and that's simply to produce flow, to facilitate flow, so that we build up the material, and the head box is applying pressure to the grout to move it along the grout flow plane. That's kind of another little picture, what we're talking about. Flow it in under the base plate or whatever. Here's a field example of using a traffic cone with the top cut out of it a little bit bigger to act as a head box. And this was on a wind project up in Ohio. You'll notice the man's footwear is kind of unique. Well, it's not because he was hunting, because there were so many rattlesnakes up there that they were wearing snake gaiters. But this is a great thing to use on job sites. Traffic cones are readily available. And if they don't want to build a head box, then that's a real good trick in order to get enough pressure on the grout to flow it. This is actually out of an old ACI guide, probably dating back to the 60s, but it showed them with a wood tamper pushing the material in with the forms up one side. Voids may or may not be avoided. I will say this also, when using cementitious grouts, try to avoid using any type of vibration, whether it be small stingers or a vibrator on a job, because it causes segregation in the grout. Another tip is, had a large commercial high-rise in downtown Los Angeles, and the grout was segregating like crazy and not coming up to compressive strength. The steel structure, and the steel structure was transferring all its vibration down through the columns, down to the base plates that we were attempting to grout. Well, guess what? With all that vibration going on, it was causing the grout to segregate and flatten out, and we had to cease all activity on the building, welding, plumbing, all of it, in order to get those columns quiet while we grouted in the structure. All right, example of a dry pack, all kinds of different geometries. Basically, that's what you have to do because the material is very, almost like Play-Doh, I guess is a good consistency analogy, but you literally have to pack it in. Now, you can use a wooden tamper. I did some dry pack machinery. They were using large 1.5 inch dowels to pack it in, and that seemed to work quite well. So anything that's available, try to avoid metal. Wood seems to like the material better and pushes in pretty good. All right, now, once grout is placed, we have to maintain curing in it. ACI says that if you've got non-thermal cycling, meaning nothing below freezing for 3 days, that's day and night, you have to protect it and cure it for 3 days. If you have thermal cycling present, meaning freeze-thaw over a period of time, you have to protect it for 7 days and maintain the temperature. You can use a curing compound, any of our Curin Seals or J9A or J10W or another product. Burlene is burlap with plastic on one side of it. That can be kept wet and will maintain temperature. Wet rags or a continuous wet cure. Most contractors hate wet cure in any way, shape, or form that makes the job site completely messy. But I've seen it used in high-performance cements, but not necessarily grouts. Wet rags are good as long as they're kept wet. All right, cold weather grouting. What are the procedures? Cement hydration stops at 32. More importantly, when it drops a little bit lower than that and it's not protected, the water that hasn't been taken up in the grout matrix will begin to freeze. When water freezes, it expands, it blows up your grout. Cold temperatures slow down the cure time on the grout too. It slows the hydration of the grout. So again, we talked about making accommodations for difficult environmental conditions like tenting. Most contractors will refer to it as a hooch, H-O-O-C-H, not to be confused with the kind you drink.
Oh, you got my...
Condition the grout. Well, you
took it away from me, Todd.
Sorry, Heidi. All right, you want to precondition the grout. That means, at minimum, keep it out in the Conact to at least get some warmth to it. because cold powder and warm water, you end up with kind of cold grout too. Hot water can be used for mixing if it's available. Blanket is necessary. Maintain temperatures between 45 and 90 for a minimum of 24 hours. Hot temperatures, same problem. You get flash set, water gets too hot, bags are too hot out in the sun. They can't get it placed and keep it flowing before it starts kicking off on you. So just the rule of thumbs are hot weather will kick it off sooner. Try to use cold water. Cold weather will slow it down and stop it from hydrating. So try to use warm water and keep the grout warm prior to use. Now we're going to get into testing. This is, without a doubt, our number one across the bear at Dayton Superior. And I would suggest that any competitor probably has to go through this as well. How many calls do we get? How many trips do we have to take to go out when we get a call saying your grout is not coming up to strength? What's going wrong? What are we doing wrong? Or your stuff's no good? Well, they're not testing it based on our published strengths. Our published strengths are based on a C109 test, which is a particular geometry for the sample. It is maintained at a particular temperature for a particular period of time. I can't tell you how many times I've gone to a job site and they're testing the grout like concrete. They're putting it in a large cylinder, and those cylinders are like 5 by 8. You've seen them on the job sites, and it's filled with grout. And the guy goes, "What?" And I said, "What? 1107 ain't, ready mix." So I've had my tussles with testing labs, but hopefully they've learned something along the way. You'll notice the difference in strengths. It's significant. The one we recommend is per ASTM right down the line. That's a brass mold and covered. You can use the brass mold uncovered and you'll lose 500 PSI. You can use the plastic molds, which are the little plexiglass guys that are not covered. And sometimes they'll put a little like ice cube tray in there. They're plastic. And you drop it down by another 2100. What we're talking about is this guy right here. This is a Schmidt mold. I took this picture about a month ago in San Francisco. And guess what? Why was I there? Because it wasn't coming up to strength. Well, I watched them mix the grout, and I made sure they measured the water. That's the other thing. If we say 1 gallon of water per 50 pounds for a flowable consistency, and you hit this strength, we mean 1 gallon of water. We don't mean I emptied out a Gatorade jar, and I think it's about a quart, or maybe more or less a quart, whatever. You got to hold their feet to the fire and make sure it is, in fact, measured water, because when we formulate these materials, the water-cement ratio, in this case, the grout water cement ratio, is highly critical. So here's a Schmidt mold. You can see these are 2 by 2 cubes, and then they are covered with a brass plate. And on the right, you can see the C-clamps are put on top. Those are to be undisturbed for a period of 24 hours. In this case, the testing lab was leaving them in a cooler out on the job site. I was okay with that. The temperatures, ambient, were running about 55. It was the Pacific Coast, so guess what? They were staying about constant. If they test the grout at 55 during the day, and then they go away at night, and they don't put it in some kind of insulated cooler, and the temperatures drop down to 32, they come back and try to get their 24-hour breaks. Guess what? Are they going to be lower or higher? They're going to be a hell of a lot lower, and it's not going to be good. So you have to maintain temperature in the test.
And so, Todd, real quick,
Yeah.
since we're almost at time, guys, if you want to put some questions in, and then I'll get Todd the questions he can answer while he's going through the products that can assist you with everything he's just taught. So go ahead and do that. And Todd, keep on going. Thanks.
All right. Just a brief review of our product line. The 1107 Advantage Grout, Sure Grip High Performance Grout, and Sure Grip Precision Grout. I'll tell you about the differences of those in a minute. The TurboGrout HP12 was specifically designed for wind towers when they started coming to us saying, "Can you get us a 12,000 PSI grout?" And we said yes, but that is basically the limit of grouts in the marketplace. Anything over that, you're going to have to move to a epoxy grout or some other type of load transfer. I'm not aware of any materials right now that will exceed an epoxy grout. And then the TurboGrout LT12 was designed to be used at lower temperatures. So at 32, 33, the hydration mechanism is still kicking off pretty good. We have an underwater grout for pier repairs and coastal supply or coastal construction. And then our last specialty item is the D490 high strength splicing grout. That grout is designed to be used with our splicing system. Specifically for that, really nothing else. I mean, you could use it. It's a high strength grout, but it is designed specifically for use with that system. And then our epoxy grout J55, also marketed as Unitex Propoxy 2500. All right, so 1107 Advantage grout meets the 1107 specification, not non-corrosive. All cases you're going to see grouts called out as please don't let them be corrosive. Well, they're not corrosive. They haven't been corrosive in 20 years, but architects and engineers are slow to update their master specs. It's pourable, pumpable, or dry pack. It has very high compressive strength, and it has controlled net positive expansion. Now, people ask me what's the difference between that and the high sure grip high performance. My experience has been a couple of things. Besides the fact that the 1107 is NSF certified for potable water, for use in potable water, that's a thing that just started about 5 or 6 years ago. And a competitor started off saying, our grouts can be used with potable water. Well, what does the ready-mix manufacturer say when he builds a concrete tank? Concrete's apparently certified with potable water? No. We get to pay the fee to NSF in order to maintain certification. It's approved by 50 of the 50 states. It's non-corrosive. It's fluid or flowable. Notice, high performance is not to be used for dry packing. If you ask me, the high performance is slightly more pumpable than the advanced grout, maybe 20 to 25% because of the type of aggregate we use in it. All right, the precision grout was brought out in order to handle the objection to gas-forming grout. So now you get a quick lesson in what are the expansion mechanisms in grout. There's really only two ways you can do it. You can do it with a gas-forming, which produces microscopic bubbles, which actually expand the grout, or you can do it with controlled ettringite. What is ettringite? Ettringite is nothing more than a type of clay. It's the thing that causes clay to swell when it gets wet. Occasionally you'll see a specification where they don't want gas forming. If that's the case, then you have to go with the sure grip precision grout. Neither of those expansion mechanisms bear on the final performance of the grouts. They work both excellently in whatever expansion mechanism you have. All right, the Turbo HP12, again, was designed for the wind turbine industry based on the strengths they were asking for. You can see that in the upper picture. The low temp is used for low temperature installations. Our data sheets will say plus 40 on the application temperatures, but truth be known, if it's kept at room temperature and the substrate's not too cold, you can drop down to those mid 30s. But the LT12 was designed specifically to perform in low temperature grouting applications. Underwater grout was designed to resist washout in underwater or tidal zone grouting applications, especially when jacketing piles. It's usually pumped from the bottom within the jacket pile as the rehab goes on, and it won't wash out. Now, does that mean you use salt water to mix it? No. In all cases, grout has to be mixed with clean, potable water, not salt water, not sewage water, nothing out of the local creek. We've seen all kinds of disasters with that over the years. So please, it has to be potable water. All right, epoxy grout, again, has its place, and there's a picture of a nice little machine with a big chunk of epoxy grout underneath it. They can be placed into fairly thick pores. 8 inches is pretty significant. We can hit 14,000 PSI in 7 days. That refers to the ASTM C579 specification. Great flow, great bond strength. Again, it takes vibration and it has excellent chemical resistance, better than a cementitious grout.
Awesome. Thanks, Todd.
All right,
so
Heidi.
This is me. So I'm going to go through here real quick, guys, because we're a little bit over, but Todd has some really great information and I wanted to get that in there. Here's the gist of it. DaneSuperior.com is the place to go for resources, even to get Todd's number if you need it. We've got a whole bunch of technical service guys out there for you to call. If you just go out to DaneSuperior.com, there's a contact form, there's chemical specifications, data sheets, product pages. Your search will be your best friend in the top right-hand corner to where you can just put in like 1107 and it'll come up with the page with all of the good information to the left of it that is pertinent to that, such as brochures or guides, online calendar calculators. Calendars, I'm thinking of my training calendar, I suppose. VOC and shelf life is an example. Wow. There we go. I got so excited with the resources, I made them bigger for you. In addition, I've already talked about the Training Tuesdays that we have. Here is the most important thing. If you need assistance, just go to those regional maps and click on Dayton Superior or Simons if you need the forming side. And then you go by state and you can find the people that are assigned to your area that can help you with what you need. It doesn't look like we have any questions, Todd. You guys are great. We had someone on here from Alaska, which that's crazy and awesome. So I think next week we should have someone from the Virgin Islands so that we can round everything out, right? What do you think? All right, that's it for today and for this week. Todd, thanks so much for joining us. I'm going to leave
Thank
this
you, Eddie.
information up here for you in case you want to get a custom training. You can scan that QR code, or there's your tech service line in case you need it as well. And until next week, everybody have a great rest of your Tuesday. Bye now.
Thank you.